the Office of Cyber Infrastructure will also put in money to build the software centres and things like this that also can be applied. So this is quite a major initiative to actually come out from the National Science Foundation. You can find similar initiatives at the DOE, both in the basic energy science side and the EDRE side. You just have to look at their budget requests. If you look towards the defence agencies, all of them have something that looks like Materials Genome Initiative. At least they all have that innovation infrastructure component built into them. So we were very excited to see the initiative become this successful. And really, at the end of the day, the only way we can judge whether it will be successful is if you make it successful. So I encourage you to start thinking beyond individual investigators, how you can form teams that you wouldn't normally form. It's a little bit hard for someone as an engineer to go get the counterparts and help from the people down in mathematics, but it's something that we should be doing if we're going to make this initiative successful. For the material science community, it's a major opportunity, and if we don't take advantage of it, I would say that the chances of another materials initiative coming along in the near term are actually quite slim. So if we don't take full advantage of this, we probably should be complaining if our funding for materials research starts to decline. It's a major opportunity for our community, and I hope that you will take full advantage of it. So let me finish with just leaving you this. This is one of the graphics that we use to talk to people about the Materials Genome Initiative, and hopefully you can see some elements there. Mike's got a smile because he's wondering what it all means. We do have to go up with educational aspects that are at lower levels than let's say university levels, and so we needed nice graphics. So if you want to find out about it, there's a website listed right at the bottom. It does tell you, it's on the White House website. It simply will tell you what the Materials Genome Initiative activities are, where upcoming events are. It will also tell you who's been receiving funding from it. So it's an important resource to actually go. So hopefully I've given you some flavor of what the Materials Genome Initiative is, and hopefully I've shown you how what we're trying to do is a little bit different, because we really do need people from different communities to come together to work at the intersections between these three circles. And if we think we can do that, or if we can do that, we actually believe that we will achieve the goals that the President set of producing materials, getting them into deployment twice as fast as we used to, and at least at some reduced cost, maybe not quite at half the cost, but certainly at a reduced cost from what we used to do. So with that, let me thank you for your attention. Thank you.
Hello. Thank you very much again for the very informative, very inspirational and uplifting talk. Thank you. And the floor now is open for questions. Maybe I can get started with a question. You can.
Can you comment whether the focus is on discovering new materials or on also better understanding of existing materials to extend lifetime and so on?
So if you notice, what we did is we said that there are 7 components to looking at materials. One is, of course, discovery. The other is deployment. And part of the deployment, and the example I cited, said that we're going to run nuclear reactors somewhere to 2 to 3 times beyond the intended design lifetime. And so most engineers in the room should be going, you're absolutely crazy to even think of that, because we put a design lifetime in there for a very specific reason, because that's what we thought the safety factor was. So basically we're taking and looking at that safety factor if we can actually eat into it. We're only going to do that if we say, can we look at the materials that are in those reactors, and can we actually assess how safe the systems are. Is the structural integrity still there? So I think the answer is yes. People are looking at not just the discovery side, but how well the materials perform. It would be quite nice if all our iPads and iPhones had a longer life than 2 years, when you think about it. So could we actually extend the use of some of these materials so we didn't send things to the landfill quite as often as we're doing that? So I think, yes, clearly part of it, right? But I think the real part and the real strength is not if we just do extending the lifetime of current materials, but at the same time we feed that information back to people who are going to look for the designing of new materials and say, these are really the characteristics that these new materials have if we want to have these properties. Right? It's that connection to make the circle, to complete it, that's going to be key. And so I think you can, from that, you can probably envision at some point the funding agencies are going to say, how do we bring together communities that are working in part 7 with part 1 and part 2, right? So that circle will be made, and the agencies, I think, will push towards making that circle. But yes, they are going to go in that. That has to be a key part of it, right? Lightweighting of vehicles is a key example, right? And then if you think of Department of Defense, you can figure out what the properties they're going to demand if you make a lighter weight vehicle. It better have properties to protect our troops that are better than the ones we have today. Right? You can't just make it lighter weight and endanger the lives of our troops. It better have better impact properties that we run today.
So, Ian, thank you for a nice talk. So is there a reason why the initiative is targeting for a factor of 2 speed up, or there are some scientific and technological barriers that you cannot go beyond a factor of 2 speed up?
Well, a factor of 2 speed up we thought was pretty aggressive in terms of what we could do. From talking with industry, they said to get some materials into deployment. If I understood your question, could we go even faster than that? We thought that was quite aggressive based on the feedback that we had. I mean, our hope would be, yes, you could go faster than that, but the certification issues are still going to be problematic, right? And if you were watching the troubles of Boeing getting their Dreamliner moving and into production, and even some of the sort of issues they had then, you can see why the factor of 2, I think, is still an aggressive one. But if we can do better than that, I'm sure there will be some industries where, I think the semiconductor industry typically does better. But if you look where they're going to go next, so rather than just advancements on current technologies, how long is it going to take them to bring in the next technology? It won't be quite in the same time frame.
You mentioned that there has been somewhat of a failure of developing software in this country for materials research. And my impression is it's not really been the money that's been given to the community, but it's been rather the funding policies for software. So is there thought to how it can change the way software is funded in this country?
Yes. So a couple of initiative days coming out of National Science Foundation will in fact change how software is funded. Our software research is funded, but not only the software research, but how do you actually then look after the software, right? You can't just make it and then send it out. Who's going to look after it, make sure the updates are all appropriate for the site, for our communities. I think so one example of such an area, I think, is at Purdue University for the Earthquake Center, right? They actually do look at new algorithms that are brought in from different places, and they assemble them into one and make sure they're all compatible with existing, right? So if you're out doing developments on one component, that component needs to plug into the master algorithm, and part of their task is to make sure that works and that software is then available to all. So I think you're going to see more places like that where we recognize there has to be an infrastructure not only for the development but for the upkeep and maintenance of the software. And I think some of the software institutes and proposals coming out from NSF are actually to do that. And I that's an absolutely essential component to the Materials Genome Initiative, and I know it's something we've discussed on the committee quite a lot. So I think the answer is yes, you guys see those. We need them. They need to be brought in as part of this whole effort.
Where do you see the role of biomaterials within the Materials Genome Initiative?
Well, maybe I did pick areas that were particular to the examples I know, but I think the biomaterials community easily fits inside this group. And one of the nice things about the Materials Innovation Platform, it doesn't really matter what material system you're talking about, whether it's a metal, a ceramic, a biomaterial, a polymer. It all works within that same framework. So biomaterials certainly is not excluded from this. And I think if you look at the actual MGI paper, you'll see human welfare as one of the key areas for advancement and development. I think that the biomaterials will play right in there. So no, you shouldn't feel excluded just because of the presentation. Certainly within, you saw some of the divisions that were listed from NSF. So biomaterials certainly resides in DMR. It resides also in CBEP and engineering. And they're partners of the NSF component, and that would be true in some of the other agencies as well. So not excluded, but expected to be a big part of it.
Ian, thanks for running this talk. I was wondering if you could talk a little bit more about making connections. That's a very important aspect of it. So with regards to industrial connections with academia, that seems to be one of the most important parts of driving this thing forward. And are the agencies actually going to foster these sorts of collaborations?
So there's two levels to the Materials Genome Initiative and those platforms that we built. We believe there is one that's the academic one, right? So that's where we'll do the fundamental science that we would then hope we can deploy up towards industry. Industry to some extent are already doing aspects of this at their own level. So if you look at the automotive manufacturers, they have been using the sort of ICME, right, the integrated computational materials engineering approach, which is a component of this. Somehow we have to connect the two platforms, right? So we have to connect the industrial component with the academic component. It is essential that we make these connections. Is it necessary for every individual group to do that? The answer to that is no. But as I said, what we're going to anticipate happening is that the small clusters of people working in each of the 7 areas, they will be brought together at some point through some hub type activity. The hub will have to make the connections and the pipelines up. Or at least that's seen as being the main pipeline up towards industry. I mean, all of us will have some path to industry, but I don't think that's actually required in, say, proposals you would send to the National Science Foundation. If you do, the approach is to go through the GOLI program. Right, so the GOLI program is encouraged, but it's not mandatory. So it is a key component, but not required for the academic side.
Any other question? You?
Could you please comment on the education aspect?
So we think that the education aspects are absolutely essential to being successful. We think that departments of material science have to figure out ways, not just material science, but departments where they have an emphasis on materials. Our mechanical engineering department on campus, for example, has a strong complement of people who work in the materials field. We have to actually figure out how we can start bringing in more computational tools into the undergraduate program and using them to enhance education so that the students are aware and ready to actually use them when they go out in industry. We also have to make them more aware of data and how data can be searched and used, and that's something that we actually don't do. We have to go beyond just educating the material science students. As I say, if people who actually design components and build components don't accept this strategy for developing new materials, discovering and saying we want to deploy them, we'll never deploy them. So we have to make sure that we're we can show and educate, say, the civil engineers, right, the aerospace engineers, that you can in fact design and build systems using this approach, and it's just going to allow you to do it faster and better than you were able to do it before. So education we see at the undergraduate, and I would say even at the graduate school or the graduate level, we need to change. And so one of the things that you'll notice that will come from NSF, since we're normally the ones with the educational aspects, is you'll see that being emphasized. One of the directorates that wasn't on there is the education directorate, but they're in fact very interested in seeing how computational tools can be brought into the classroom and then assessing how effective they're being used in terms of teaching people. So I think you're going to see partnerships between, at least within NSF, between what we do in the Materials Genome Initiative with the Education Directorate to try and come up with new ways to educate tomorrow's engineers. Right. So far, the only university I know of that's really made a significant change in their undergraduate education program to bring in computational tools is Ohio State University. They've actually gone and revised their entire undergraduate curriculum and now actually have a significant component of computational material science included. They've recognized its importance and they're moving in that direction.
Ian, let me ask you a question. You clearly stated that your goal is to discover materials twice as fast at half the cost, including the deployment of the technology. I think this is a huge goal. This is very bold. This is quite big. And when I think about it, and then I looked at your slide that shows the funding, and then I counted it's around $500 million for that. This seems to me to be very little. For example, last week I was at KAUST in Saudi Arabia. The king there made an endowment to KAUST of many billions of dollars. Now we are talking about, for such a huge goal, funding in the range of $500 million to $1 billion. I think this is very shy of the goal. Am I out of my mind?
Well, I'd never say that about you, yes and no, right? The no part comes when we see some of the other initiatives for energy, for water, for clean air, for all of the science that we're actually doing, whether it's, I think you're going to see that some of the new projects and programs that are going to come along are going to be follow the materials innovation infrastructure, but they're not necessarily going to be using that pot of the 50 million or whatever it is turns out to be at NSF, because others are going to use the same structure to attack problems. So you could say, for example, MERSECs at NSF, for example, are partly the way to doing this already. The part they don't really include usually is the data component. But you could see suddenly saying the MERSECs of the future may in fact mirror that innovation platform. So you've suddenly gone from 50 million, you've added another 50 odd million into the program, or some fraction of that in. And the same is true. The Earthquake Center, for example, is another example that follows it. It's a center that's already there, but it uses the same innovation type infrastructure. So I think you have to look at it as a seed money that's going to build and bring in and draw in other projects, because it is so versatile a platform that we are going to see effectively more dollars than is listed there coming in. Right, I think one of the other aspects people should be aware of, NSF, DOE also have cyber and data-enabled science and engineering initiatives coming out. This platform fits perfectly within it. So I think the total amount of dollars that we're going to invest in the end is going to be much larger. Could we do more if we had more dollars? I think so, but you should know getting extra money and getting even anything listed at on the one NSF side is a priority, is quite a challenge.
Yeah, there have been a lot of interest in metamaterials in the last decade. Can you comment on what role metamaterials will play in this new initiative, or it would be very different?
Well, I think, with the metamaterials, you can look at, is there still room for discovery, property improvements? Right, there's areas there. How we want to deploy them. So again, it doesn't matter which material you put there. They all, advances in them and their deployment and use all fit within that same platform. So none of the agencies are really saying only this specific material can actually be included, or this materials with this specific property can be included. It's not intended to be that. And the reason we didn't prescribe it, so I should say that the defense agencies wanted to be very prescriptive for the types of materials we would look at for obvious reasons. Both DOE and NSF said, well, we want you, the community, to decide what materials we should look at using this platform. It should be up to us. And so that's why it doesn't target either biomaterials, metamaterials, metals, ceramics. It's you, the community, that's going to decide where it's going to be applied. And I think that's the right approach, rather than, as in the government agencies, defining those. Right?
Any other question? All right. Well, I would like to thank Ian again, and also I would like to thank all of you. I really appreciate the large number of questions and this interaction. Your talk was highly dynamic. Maybe this can be a model for all the other talks. I think this kind of a discussion is very uplifting and very informative and quite interesting for our CSE symposium. Ian, thank you very much. We really appreciate you coming here and the wonderful lecture that you have delivered. Ladies and gentlemen, let's thank Dean Ian Robertson.